right. So we are here in Unit 7.2. We're going to pick up, we were just in the room, we were having a conversation about the quirks of Inkscape and vectors, which is a lot of fun. And it's good to have those conversations if you ever get a chance in a given time. But it was, it's fun to do and all based around the different experiences that we've had. And so we're going to continue on our experiences with vector designs this week, but specifically shift our focus over to vector designs as they relate to the laser, which is a fun other tool. Honestly, I would say that probably if I were to take all of the tools in MakeHaven and have to choose one for my favorite, it's probably the laser. Just because it's so fast, does such a great job, and it makes for really nice products without a ton of work. So what we're going to talk about today is vector design and some of these concepts. So we're going to talk about engraving and cutting. We'll talk about different materials, raster and vector, sort of how that fits in this context. Talk about some advanced design ideas, some DXFs and what the heck those things are, and then laser projects to go along with. There's a ton of overlap between this and the vinyl cutter work, but it's good to just think about what's sort of the differences and what are those distinction points where you'd want to change your design. So laser engraving and vector cutting. First off, before we even get to that, I suppose I should have a different title slide. Let's talk a little bit about lasers. Laser is an acronym, in case you didn't know, just like SCUBA is an acronym. It's light amplification by stimulated emission radiation, which is a really fun sciencey term. And stimulated emission is its own concept where you hit a particle with a photon and 2 photons come out. That's stimulated emission. You just do that inside of a little tube and you get all this weird light that pops out. And it's really an interesting effect. I had a physics professor years ago who said, lasers are the only thing that we have done, humans, that nature doesn't do on its own, which is a really interesting perspective. I don't even know if that's really true, but it's fascinating. And so lasers take light and they make very intense light that is coherent and has a lot of different interesting properties. But basically, all it is a super intense flashlight where all the light lines up and rows together like a rowing team. And basically, you dump all of that light power through a lens, very much like a magnifying glass. And when you do that, your column of light, your parallel beams of light that come in like this, all parallel, they pass through that lens. It has to be specially treated lens so it doesn't burn up or anything. And it focuses all that energy into just one individual point in 3D space. At that point, all the energy from all that light focuses into one spot, and that's where the magic happens. That's where it will vaporize away material, which is what's happening inside a laser. Our lasers won't, but there's some lasers that are so good at focusing energy there that they can actually turn air into plasma. And the like femtosecond lasers that'll do that in a physics lab are really cool because you turn them on and it just sounds like the air is screaming and the air is turned into you've got a little tiny point of the sun right there in the room. But our laser is much more calm than those, but it's still the same idea. You take a whole bunch of light energy, you focus it all into one area, and you get this material to cut in this green region. The focal point you want to have be right on the surface or just below the surface of the material that you want to cut, which is this green stripe. And then there's a black or honeycomb, a black surface or a honeycomb surface beneath it that's usually metallic so that it can dissipate any of the energy that's below that focal point. By the time it's spreading out past the focal point, it's also a lot less likely to do any burning or anything. But it's good to have things that will absorb and spread out that energy really quickly. But it's really cool. So there's a few different things to think about with this. If you want to really nerd out on the physics optics, the focal length plays a major factor in here. If you have a 2-inch focal length, you're going to have more of a cone shape. We have a 4-inch lens, and that's got a more extended cone, so you can get into deeper things with the 4-inch lens. Because that cone of light is just distended further. So it's better at making it down into a cavity to cut things. But basically, this will work to cut most anything. But our requirements here is that vapors need to be non-toxic, so you have to be careful about what you're putting in. And the other thing is that your material that you want to cut can't dissipate the energy faster than you put it in. So metals don't cut well in the laser because they're very thermally conductive. And so all that energy spreads out before it has a chance to really burn through the thing to vaporize the material. But it's fascinating. If you really want to nerd out on lasers, I'm in. I definitely have some optics books at home from my college days. But the laser is a fascinating tool that can do all sorts of stuff. So we talked about vector last week a lot, and how you couldn't really raster on the vinyl cutter unless you're using a pen and some weird stuff. But the laser totally can. And so you can do both raster and vector with the laser. They look a little different than they do on a computer, but both of those are possible processes. Still thinking about the optics this way, you can use them for cutting tools and you can use them for engraving tools. This is a Christmas ornament that we made a few years ago. My wife is from Ann Arbor, Michigan. So here's a little heart where Ann Arbor is, and then the state and a little ornament shape. This is vector cut on the outside edge and then rastered in for all those darkened areas. This is a good example of how the laser can do both of those processes even within one job. It's really nice. This green is laser cut fabric laid onto some laser cut wood. There's cardboard lasers really well. You can do fun things with wood if you want to get it to curve by cutting a whole bunch of kerfs. It's really a neat trick. But really, you want to think about that focal point all the time as you're doing this. There's a few details that we'll look at and we'll try and sort out. But ever present in your mind while you're thinking about the laser is what's going on with the optics and where's the focal point in space. You want it to be just on the surface. Over time, a laser's lens can get dirty and need replaced. And that's a thing that happens from time to time. It's definitely an ask Leor to do it or a facilitator to do it kind of thing, because you can't touch those lenses. Otherwise, you get oils on them and then they start to build up heat and they deteriorate a lot faster. But it's totally maintainable. I have replaced them on lasers before. Steve, you probably have, right? It's a doable job. You just need to be conscious of it. An old laser will not burn nearly as well. A new laser, I bought one with a wrong focal length, so it's out of focus, but you can see how much darker the exact same settings were able to burn. That lens is an important part of the whole equation. And our lasers in MakeHaven, if you read the Slack, there's a lot of superstition about which one's better for which. And I think probably it boils down to the lenses are always in separate states of like how far along are they in their lifespan, probably sort of a little bit. And so there's some of those things to think about, but this is really a process that you're enabled to do by having both sides of these things be possible. So yeah.
Would the fabric down first on the wood and leave it all together, or you do it separately?
It's a good question. Did I do the fabric first and then the wood, or do them together? And I cut them separately, and because the shape is so easy to register, I just cut them. I cut the fabric and the wood separate from each other because they're way different settings, and then I glued them together afterwards. And I suppose you could try and do it together, but I didn't want any burn marks on the fabric, so I did that with the fabric settings and the wood with the wood settings, and then brought them together. Worked well. And then this is like a little metal compass coin that I bought at maybe Joann Fabrics or something, and then just cut a hole for it and plopped it in. Happened to be about the same thickness as the felt. This is a quick way to impress a mother-in-law if you ever have a need of such things. So it's a good trick. The tablet holder. But if we're talking about lasers, if we're trying to make sense of how they work, this is what I want you to think about if you're trying to imagine what's going on in the back side of the laser tube. Sort of a glass cylinder with a beam of light going on inside. We don't have red lasers. They're clear, they're infrared, you can't see them. But it's still the right kind of idea. And essentially all of our lasers run on these three properties: a power property, a speed property for the motion of the laser lens, and then PPI, or pulses per inch. So these three factors, for anybody who's ever played with like really good photography, there's three properties there. There's your ISO, your f-stop, and your aperture. Those three properties you have to get just right to get those balanced, to get perfect pictures. And pretty much the same thing is true for the laser. Nailing these properties to be exactly the right combo is definitely got an art to it. We have a guide table right here that will show you sort of what all of these are. This is, and hey, it's you. That's you on the thing. You can get all these people to badge you at different times. And then down here's this table. This is our recommendations for what the best settings would be. But all of that is sort of the best guesses that we have. It's not necessarily going to be exactly that. If the lens is deteriorated a little or whatever, or maybe you're getting too much burning, so you want to half the power and do a couple passes, there's a few adjustments you can make, but mostly these are great places to get started. And so if you're ever trying a new material, this is the place to go. Also, that tab is like always open on the computers downstairs.
I realized it said glass / crystal.
Yeah.
So you ever laser like a crystal, like a I don't know, like amethyst or like
Oh,
that?
I have not personally, but glass is something that's really fun to laser. I am shocked that we haven't yet gotten one of the things to a rotary attachment to put a pint glass on so you can laser those. Those are lots of fun. I feel like we should all put it on the wish list and aggressively go after getting one. We had one and it broke. Oh, that's terrible. Oh, that's so you like plug it into the laser and it'll rotate the pint glass. And instead of cutting out a square, it will do sort of back and forth motion in one dimension with the normal laser parts. And then the second dimension comes from rolling the glass. So you can laser engrave things onto the pint glass or a wine glass or onto a bottle if you've got a fancy, or if you have some round, when I'm thinking, when it says crystal, I'm thinking like a fancy Scotch glass kind of crystal.
Without the rotary, the focal length has some give to it, right? So you can get away with, I mean, I've done like 3/4 of an inch logo on a champagne flute, just squeezed it in before it kind of fell out of focal range to the side.
That's totally true. But if you want the nice crisp,
Yeah.
getting one of those rotary attachments is I think that we can make that happen. But so let's that aside, still getting the settings dialed in is really important. And essentially you want to think about how the dynamic works, because if we're trying to orient these three different properties, more power is more burning, more PPI is more burning, and oddly for speed, less speed. It acts inverse, right? The slower you move past something, the more you're going to burn it, right? So in the case of power and PPI, crank those numbers up and it'll go with, you'll burn through something more, crank the speed down and you'll burn through something more. And so you got to get the dynamics just right. PPI is essentially directly related to how much you're going to burn. So some materials like paper, if you turn the PPI up past 100, you're good luck. Like it's going to just turn to a crisp. But acrylic really needs a lot of heat dumped into it so that it can vaporize the plastic away. And then some plastics will never vaporize, like polycarbonate just doesn't burn right. And so, which is an important thing to think about as you're doing this stuff. So looking at these three, thinking about the dynamic, if the settings aren't working for you, check to make sure you've really got the material you think you do, is the first one, especially for plastics. And then try and adjust these around until you get the settings that you want. It's always good if you can to do a test cut on something that's the same material and then do your final project if you can. But sometimes you just can't. So you've got to like shoot from the hip and hope that it works, but it'll all be fine. Another thing with the laser is that it really is vaporizing away the material. So when you burn wood, it's turning it straight to a gas. You see like a point of light and it's going from a solid straight past the liquid all the way to a gas, and then it's carried away as a vapor. And that's fundamentally how it's working. You can imagine like your science teacher sometime in life saying water, ice, and steam. Those are all three phases of matter. In the case of the laser, it goes straight from solid to gas, nothing in between. And that's so that it works well. If something gets mushy in an in-between phase, it's not going to laser well because it'll liquefy and then sort of re-stick back together. If you don't put enough energy into acrylic, it'll do that. And so you've got to make sure that you get the right balance. But that also means that you're going to have to ventilate away all of those vaporized materials. So it's not the same as like smoke from a campfire, although it can smell similar. This is vaporized wood that happened right now. And so you need to crank this out. There's a ventilation system that's really big and robust attached to all the lasers. Make sure anytime you're using it, you turn it on. Another thing that's important to think about is there's going to be small flames in the laser. It's going to happen. If anyone's ever done the trick where you like blow out a candle and then you can immediately light it through its own smoke, it's a fun trick. If you haven't ever played that bar trick, we can do it sometime. But you are going to have some burning because you've got so much heat in a small area. Little tiny flames are going to happen, but you want to be watching it actively. And if it's a sustained flame, that's a problem. If the laser leaves and there's still a fire, that's a big issue that we need to solve. And when you get badged, you'll talk about the fire extinguisher, how to use that, fire blankets, the whole bit. It's not something that I worry about on a regular basis, but you just need to be aware that like a little flame popping up is something to be conscious of and start watching closer, but not necessarily an immediately like full red alarm, have to stop everything. So those are the safety concerns with the laser. Otherwise, it's a super safe machine. Everything happens inside the box. It's all totally fine. Even if you open the lid while it's running, the laser cuts off immediately. So it's not like you can even accidentally shoot laser beams into the room, which is perfect. That's the right kind of safety. So those are all important things to take into account. One thing though is the material matters. Never, ever, ever put polyvinyl chloride into the laser. PVC, like PVC pipes, if you burn that and vaporize it, a chemical reaction happens and you get chlorine gas, which is mustard gas. We do not want that in the room for the humans or the laser. It's toxic and corrosive and very, very bad. So some materials can't be used at all. Other materials are totally fine to use. And then there's some that could be used, but they just don't work well. And so thinking about that dynamic, we do have a list in here of a material short list. And this is in the slides. You can totally get to this. This is a subset from the webpage. And I bolded in my favorites. I really like 3mm craft plywood, which is it's really great. That's what I did. 6mm craft plywood was that Michigan tablet stand, but 3mm is thinner. It works. That's 1/8 of an inch. Works great. Acrylic is magical. Comes out with like a glassy finish. It works really nicely, and it works super well. Whereas polycarbonate that looks identical to the eye, it's really hard to tell the difference. Almost doesn't work at all. Lots of smoke, lots of fire. And it doesn't really separate. You just can't dump. It's the same. Polycarbonate is the same stuff that bulletproof glass is made out of. And so for that purpose, you kind of don't want it to be easily destructible. And unfortunately, that means it doesn't laser well. There's other plastics that are fun. Leather's kind of neat. It smells like a barbecue, which is fun. Fabric, you want to do test cuts on fabric. There were some people in the class last year who did some really cool engravings on fabric. Like if you laser engrave on denim, it turns white, which is a really cool stark effect. So if you wanted to put a very light engraving across your leg, you could totally do that by putting jeans into the laser. It's a really neat look. Paper works super well if you want to do pop-up cards. Corrugated cardboard is one of my favorites. I used to buy sheets of that by the thousand. That was the perfect fit for our laser at the school, because it's trash, right? Corrugated cardboard in our modern world is mostly garbage. However, most corrugated cardboard that like you get in a simple Amazon box has a 220-pound edge crush test rating. So like if you build something out of corrugated cardboard, you can probably stand on it if it's built the right way.
To sell furniture.
Yeah.
Just sheet upon sheet of corrugated cardboard.
Yeah, it's kind of amazing how cardboard can be used in all sorts of different ways. That was a perennial project that I'd have for my high schoolers, where we'd engineer a cube out of cardboard. You have to get it so that it would fit and like make it work so that I could stand on it. Was like a big dramatic test at the end of the day, right? It was kind of fun. But it's really nice because it works well. And if you're off a little bit in your dimensions, it squishes into the fit that you want. So it's a great test prototype material for sure. But let's first talk about what can you do with the laser. So these are some of the materials, some of the concerns, a little bit of the science, but the engraving for the laser is what a lot of people are here for. And this is what it looks like to do engraving. Engraving is when you remove some of the material, you burn it away. It usually darkens the material. And so this was the only GIF I could find of a really nice engraving. It's you know, so this is cutting away at that surface of the, it looks like it's wood. It's cutting away at the surface and you get, it's darkening because it's burning the wood, right? And so just like a wood burning tool, you get some darkening that happens. That's the reason why it looks darker here. And it's going back and forth, raking across the surface, just like a raster image is drawn pixel by pixel. The laser's sweeping across, drawing in, burning in pixel by pixel from the material, drawing in exactly the same way that it draws colors on a computer screen. And so it's a really fascinating process. The detail can be really, really high, and it works really well. One thing that's a little dicey is you can get some burning that happens here. You can see on this design box text. Watch when it's in the process of burning, and then as soon as it starts to get to this bottom, you can see some smoke fill in on the E and the S really, really carefully if you're looking at it close. And so some of that dynamic you want to think about as you're doing it. But another thing that happens with this is that this process takes a while. I roughly think that about 1 inch squared is about 1 minute on the laser, ballparky sort of size. And so it gives you a reasonable expectation. Something that's 4 inches by 4 inches is going to be 16 minutes. And if you get much bigger, it takes a lot longer. And this is definitely something that you want to take into account. If you have a giant piece that you're going to engrave, it's going to take you a while. But most laser jobs are pretty quick, other than this effect. Another thing, if you're going to be engraving on the laser, is usually you'll want to think about how that engraving is going to work. And this is something that I've learned with lots of experience with high schoolers who want to laser cut their favorite cartoon characters. And so here's SpongeBob in his original colors. This should be able to be rastered into the laser. But the problem is that typically this, the laser, like printer drivers will take an image like this, convert it straight to grayscale, and then burn based on the grayscale of the image. And if it doesn't grayscale well, you usually get a bad quality for your engraving. So what I have started to do is make false color maps of the image. So here you can see how I took sort of the shapes as from the SVG and then turned them into different colors. Like I grouped them together, sort of, some of them get flattened, some of them get put in different ways. But since you can choose your laser cut settings by color, I'll choose different primary colors that I can then finally tune in the laser settings for. So like I definitely want the blue to be a little darker than the yellow. So I'll make the blue settings a little bit deeper than the yellow. And I want the red and green to look different so you can differentiate the tie from the pants. And so you can get that effect. And so original SpongeBob here might get remapped to these colors, and then fingers crossed, that's how your laser cut turns out. That is an Inkscape mock-up of a laser cut, not a real laser cut, but this is what you're hoping for. And so that's a lot of detail in an engraving. There's a member who will come in and pretty regularly, he'll raster engrave some anime scene that he's put together with a quote. Do you know the name of the person? Max. Max will come in and do that pretty regularly. I assume he's doing these sorts of things or turning it into some sort of false color map. Typically, if you've got a lot of shapes going on, this is something you're going to have to very actively plan for. If you've got just a couple of colors, it might be fine to just like go for it and see what happens. But the more control you want to have over it, the better. Another thing is that in a map like this, they usually color states separately so that you can tell the edges really cleanly. That's a strategy that I use here, is that I never want to have the same or very similar settings right up against each other. Even if you're sort of overblowing the color differences when you do it, you just want to have a contrast across any one edge of a shape is a really important thing to think about if you're really leaning heavy into the engraving process for the laser. So there's some of those pieces to think about. This all spills out of the Inkscape to universal laser settings. So once you start to play around in there, this is something that you'll start to think about a lot more. This is not like your first engraving sort of consideration, but it's definitely, if you try and get more advanced, this is something you'll want to think about. But you can get some really nice engravings that look like that. Vector, this is where I think the laser really shines. This is my favorite use of the laser because it's a lot faster and you get a lot of cool stuff. Vector things don't rake across the surface like a raster does. They instead cut along a defined path. Very much this idea of WYSIWYG still holds. You'll want to think very actively about where it's going to cut. So our idea of the bear last year, that the atomic bear, is real important. So you can't just pull down an image and cut because it'll cut anywhere where there's a line. And there's still a lot of these same best practices. Nothing really new here from vinyl to laser, just things to think about again. But vector cutting is cut like this. So you can see how the laser is not raking back and forth. It's tracing out along the path. That's what vector looks like in the laser. And so a vector shape will define exactly where it's going to follow. And this is where the SVG path standard really counts. So this is where you're able to control, and it's not just raking across. The automatic raking is what's raster. You can still do raster effects with this, sort of confusingly, but the main idea of a vector is that you have this path that it follows. And so you might cut it out of a piece of black mat board and get this sort of a look, or cut it out of a piece of veneer and put it on top of another Christmas ornament. Merry COVIDmas. This was our more recent one. And so you've got this sort of a look. This was all a vector cut though. There was no raster to the state. I just defined a whole bunch of lines and then had 2020 cut out from them. So did some Boolean work with the shape of Connecticut and the shape of those numbers to remove lines where I wanted. And so it gave a raster-like effect, but those were all vectors that I was able to define and control. So I wanted them to be a checker pattern instead of like raking back and forth across the surface. So there's a ton of opportunity with the vector process, but estimating time is a little trickier because this is turning in a bunch of weird ways. The speed, time, and like linear inches of the cut really are what determine your cut time. So a lot of vector cuts, if you've got big shapes with lots of empty space, they can happen really fast. I was doing cuts downstairs, making nice things. They took a minute, right? A 1 minute cut to make something nice can really work. And I think that in the case of these ornaments, if I remember right from last year, to cut the outline was 20 seconds. And then to cut the state was more like 3 or 4 minutes to cut the state itself, because it was going back and forth across every one of those lines and it had to do it in a raster-like sort of way. So the time that you use for a cut is definitely based on how many inches it has to travel. And then also how much does the tool need to accelerate, which is an important detail. So if you're thinking about cutting, especially, you need to start to think about managing what's going to happen to that vaporized material. And so I think a lot about the material that I want to cut and then top and bottom masking when I'm doing this, especially if you want to have a nice surface finish. That raster where the letters turn dark, that was from smoke depositing on the surface. So in the same way that we used masking tape to sort of cover the vinyl stickers and pick them up, a lot of acrylic will come with a masking on its top or its bottom so you don't mar it. And then there's straight masking tape. You can totally do that and laser cut right through it. If you've got a nice piece of wood that you don't want to pick up any burn marks while you're doing that, you don't want any soot to deposit on the wood, I would totally recommend you cover it with masking tape so that when you engrave it, all the smoke deposits on the tape, and then you can remove the tape and all the smoke is gone. It like didn't stick to the wood at all. There's a couple other notes that one of the things that's wild is that when the laser is glowing white, that is glowing hot. It's not a fire, it's vaporizing and just burninating everything without actually doing anything. So it's glowing incandescently, which is its own entire fun science nerd thing called black body radiation. That's what the sun does. Like the sun isn't on fire, it's glowing hot. Anyways, but this vaporized material is something that needs to be managed. The vacuum pulls it out. The masking can block it. If you're cutting acrylic, I think the best way to do it is to take the top masking off, usually, so that the smoke can just leave for acrylic. Sometimes I find that top masking on acrylic, it'll stick there and like do weird things. For wood, I want a top masking. Acrylic, I usually take the top masking off. For acrylic, I leave the bottom masking because there the smoke's kind of trapped and it helps to keep it separate from the plastic. Another thing that's really important is that your walls here for the material aren't always going to be vertical, right? They'll probably have a taper to them because your focal point is where it's going to be the widest. And if you're a little off that focal point, it'll be tapered in a little bit. Still burned, but not quite as much, or very much in the same way as the water jet. Sort of the laser vaporizes on its way down. It has to vaporize down through the material. And so it'll vaporize a little bit more at the top than it will at the bottom. If you're cutting through 1/4 inch thick plywood, what I'll usually do is do a cut at the top level and then bump the focal point, bump the bed up just a hair, just one bump, so that my focal point is like at the top of the wood, and then cut it again with the focal point at the bottom of the wood to get sort of a straighter cut and to make sure that it's more separated. Because a 1/4 inch, especially for the 2-inch lens, is sort of like at the border of what it's good at doing. So thinking about this piece is a good way to do some more advanced level lasering. It's probably not for the first round, but if you've already got some laser experience, it's a good thing to think about. Cool. Another thing is that when you're vaporizing away material, there's a kerf. So just like the table saw, when you run the table saw blade through a piece of wood, you lose 1/8 of an inch because the table saw blade is that big. The laser is not got a physical blade that's removing anything, but it still removes material. And so if you want to make an exactly 1-inch wide square, you won't be able to make it exactly 1-inch wide because the kerf is going to cut away in some dimension or another. Up here, I did a test where I cut slots of all sorts of different sizes because I wanted to hit exactly the thickness of the cardboard. And so I labeled them for what thickness they were and then sort of fit them together until I got a perfect fit. Most of the time, kerf won't matter that much. And so you won't need to worry about it. It's for if you're going for perfect press fit things that fit together really nicely. So like an example are these little snowflake things I cut out so that students could sort of keep themselves busy if they were distractible by arranging them into fun different shapes while they're getting bored in classes or whatever. Or these were kids that built a cardboard car. And so their car, which I could easily stand on and hold me up, this needed to have a fit that was really nice and tight so that those pieces wouldn't wobble at all, because that car had to break with some precision. Or like, this is a very cheap and admittedly lazy silverware tray that I had in a kitchen drawer. And so that needed to fit reasonably well so that it wouldn't fall apart. So different cases, you might have to think about kerf in different ways, but it definitely has some advantages also. Like the kerf adds a weakness, but in a prescribed dimension. So this kerf cut here lets you take a solid piece of plywood and bend it like it's nothing. And very interestingly, is it weakens it in this dimension, but not in this one, because you have continuous sticks of wood all the way up and down. So you retain full strength on that one edge, but you can bend it just fine in the other. It's a really cool way to have solid, mostly solid wood pieces that have that sort of strength, but you can bend like a floppy wet noodle. And so it's lots of fun. This looks like it's 1/8 inch ply, 3mm ply. Yeah, that's a little object, but you can definitely do it with 3/4 inch plywood. And so that kerf bending trick is a really good trick that will generalize across things, but it's super fun with the laser to make this work well. We're gonna see, and then maybe it's the next, yeah, there's some slides coming up where you can see exactly, there's some tools to help you make cool kerf cut boxes really quickly. But here's some advanced ideas. So we've talked about a lot, but there's still some more. If you're thinking for the laser, it's a little different than the vinyl cutter where everything sticks to a backing. Once you enter the laser, you have to start to think about islands and fonts. And islands are really an important part of this design. And this poster is spray painted onto something. And with a spray paint template, you got to think about what the spray paint artist wants to do. They want to run up to the side of a building, hold this mask up, and then spray so that the sign's on, and then run away. Right? They don't want to have to arrange a bunch of things, get it all to work, unless they're really genuinely an artist and not just like tagging things. But they want to have all these detailed pieces fit together. And so if you look at this, if you stare at this image long enough, all of the different features are connected where there's no spray paint, it's one continuous piece. So you can see sort of this ear is cut out, but then the parts around the ear keep it connected to the sidewall. And like there's totally an eye here and an eyebrow, but those are bridged together so that nothing is just cut and separated. So thinking about islands is really important. And that's something that's been considered for you in lots of different ways. Stencil fonts are the key example. Stencil fonts like this have those marks in them so that there's no isolation. Like the E, the inside of the E would fall apart if it didn't have that little stencil connector here and here. Or in the G, having connectors on top and bottom make this a lot more stable. or like inside of the A, there's a connector here and there'd be a connector down over here. The R is the same deal. The inside of the S usually gets connectors. Those things keep you from having islands that are either very weak or going to fall out. And it definitely takes some mind bending to look at that long enough to really see every single one of them. But if you're looking for a stencil font, that's one way to do it. And to be clear, that's so that you lose the parts, like in this T, that you lose the parts that make the T and you get to keep the rest of the material. With the laser, sometimes you don't want to do it that way. So you want to go the other way. And so anti-stencil is also a concept for the laser, where you want all of your text to stay together. And then cursive is really nice because all the letters are connected, right? And so if you want to have the positive of the text, you want to have the text itself, using cursive fonts is a nice way to connect all those things together. Like in this anti-stencil example, which is a weird font, admittedly, all of the letters in here are connected together by little tiny bridges. And even though they might be delicate, they would be one piece that would register together. Whereas the stencil, you kind of want the negative of the text, the opposite of the text. And so thinking about that dynamic is a really interesting high-level art discussion if you want to go into it. It's not a problem in the vinyl cutter because the backing solves it for you, but in the laser, it starts to become one. And it's only if you cut all the way through. If you're engraving, doesn't matter. That's all not a problem. This is if you're cutting straight through for solid letters of different materials. So that's totally something to think about. A solution for this, and essentially how stencil fonts work, is they add tabs. The waterjet is super good at this. If you're in the OMAC software and you have some shape that's going to fall apart, this is a bracket that I think we talked about. It just interrupts the design. So like you have a cursor, if you open the tab tool, you can be near a line, you press this Control T and it just adds a tab because it knows this is a problem in that software because the waterjet's always going to have this problem. It doesn't engrave. And so they made a really nice feature to just add tabs in. And so you press a button and the pink is the cut line. And so the cut gets interrupted and then it comes over here and then it starts to cut again on that side. And that little connector piece keeps the parts together. If you're doing the laser, you'll have to do that more manually, but it's still totally possible to do. And I don't know if you've ever bought like kits to be assembled of like little 3mm wood dinosaurs or whatever. Usually they come in a sheet and you have to like cut the tabs and then they all come apart. So it's way easier to ship them all in sheets that come that way. So this is something totally to do. Usually I don't do that and just watch for pieces to drop in the laser. Like once the cut's complete, they'll fall out from the larger material. And that's a great way to know that your cut made it all the way through. So that nailing that dynamic, thinking about where you want it to land in your particular application is important, but tabs as a concept can be helpful. When we get to CNC, there's a lot more of that. Another thing that's really cool in the laser specifically, if you're pulling things out, is thinking really nice and hard about positive and negative space. There's a lot of opportunity for creativity. I like to do vector cuts on the laser because the materials can be so stark when put right next to each other versus engravings. And so then I'm usually thinking about this dynamic of positive and negative space, right? Like in this MakeHaven logo that I've altered, there's not really a square there. It definitely looks like a square, but it's the positive negative space of the text versus the square. If I were to cut that, there would be no square shape that falls out of it, right? None of the shapes would be a square. You'd have sort of the weird spaces and build it to look like a square. Tons of these optical illusions make for all sorts of cool stuff. This like 7-sided shape that's super common in Islamic tile work is really fascinating. There's some cool examples of positive and negative art that you can look at. This is somebody else's artwork that's really cool where they use negative space really nicely. And this is graphic art, but you can imagine sort of laser projects that spill out of this, like Songbird. That's fun. It's almost punny. There's all sorts of different things that you can do using positive and negative space creatively, just to be inspired by all sorts of different people and their work. Tessellation, no, stop. I do like tessellations like this can be really fun. I would do this a lot. I worked with a lot of elementary art teachers to do tessellations for their little kids. And so it's really cool what you can get with patterns and shapes that cut out like this. So there's tons of cool opportunity for that to work. MC Escher's work is really fascinating to see how that all fits together. And And so there's tons of cool things to think about with that. This is a great easy win. If you want to go have a fun time on the laser and be instantly amazed, you want to go to makercase.com and cut a box, or to go to boxes.py, which is easily just as good. But in these cases, I'm going to click these links and open them up. You can say, I want a box of this size, and then it will just make it for you. So here's MakerCase. Let's say we want a basic box. You come into here and you say that you want a box that's 4 inches by 4 inches. I want to have fingers on the edges, and I want the fingers to be like that. And so here's the design without a whole lot of work. You can click and just sort of rotate it around to see what's going to happen. And then on MakerCase, with all of their, ads and things and all of that, it is a free service. You come down here and you say, download box plans. There's the plans. You download these and you can just cut them. Those are directly read. You say, I want to cut just the red lines, and boom, it works. Yep. These are, you can download them as DXFs, SVGs, or maybe, I think those are your two options. You can put labels, you can put no labels, you can do line formatting, you can do kerf and corner compensation, all that sort of stuff. There's a very tiny, I think that there's a very tiny community of people who really nerd out on doing this online, because they didn't always have this kerf and corner compensation setting. But boxes.py from Festi.io, they popped into existence and they really nailed it on always having the kerf cutting setting. This particular one online has some really cool stuff where you can do boxes with flex. They're not as good at having a showy website, but like here's Flexbox with a living hinge. So here's, if you want to make one of these, you click on this link and boom, now you're designing that box. You put in the settings that you want, and this is what it's going to end up looking like. So this is a really cool, there's a lot more settings and things to adjust, but it's a lot of fun.
Is there a site like that just for generally cutting flexi pieces, not in the box context?
No, but it's way easier than you'd expect. You just draw on a bunch of lines and then it flexes perpendicular to those lines.
Okay.
So
Yeah, like they're not always perfect, but there's some where you can actually get like lateral flex instead of, it doesn't work as well, but you can like shift your material slightly on the axis.
Got it.
Yep.
And it's usually just a repeating pattern, paste in and scale around.
Yeah.
Yep. So there's all sorts of cool examples. I like this site a lot. It's a little, I like that it's not trying to sell me things, first off, but then there's all sorts of different cool things that you can do from boxes.py. And so this is a nice, easy win. If you get better at this, you have a seat, Ada. Yeah. Ada was in the class last year, is here to join us. And so we're just talking about laser things. So when you use this 2.5D construction more generally, beyond just boxes.py and MakerCase, you can do all sorts of stuff. Everything that's pictured here are unique designs that I myself have made. So once you get better at that, you can start to apply this in different ways. This is sort of a fun procedure where you can use different materials along with that. Here's a flex kerf bent exterior. This was one of the Barbot versions. This was a student who was building a thing out of 3mm ply. This is acrylic that was cut and bent. And then this is full size plywood that was cut on a CNC. Not a laser, but the same idea. So it scales really well. Using this with wood glue works really nicely, but you can also do it with nuts and bolts. I call this trap nut joinery, which is a terrible name, but it works really nicely to use a bolt and a nut where the nut is sort of wrenched in by the material, and you can fasten things and then unfasten them. Really important if you want to build and unbuild a thing a lot of different times, because you've got teenagers who are making things and they can never make up their mind on what's the best plan, or you've got to test it a bunch of times to figure it out. But there's all sorts of interesting and complicated ways that you can put stuff together. And this is a really fun one. You have tabs for alignment and sort of a hole and a slot. And getting this geometry to work with your particular nuts and bolts is fun. I have it at home. I made a tempeh incubator, and it was all assembled with this because I wasn't sure that it was going to stay the same. So I could assemble and disassemble it. And then laser kerf bending, definitely more broadly than just boxes.py, can be used across the board for all sorts of stuff. This looks like it's a watch, if I'm reading that right. But then there's kerf bending in all sorts of different patterns. If you bend and cut in different ways, you get different flexibilities. So some are flexible in multiple dimensions. Some are only flexible in one axis. There's all sorts of cool opportunities for this. They do also stretch a little bit. So here's straight lines that work well for a coffee mug insulator. There's all sorts of cool things that are available within this.
The triangle at the bottom, it looks like a little table.
Yeah,
The bent one.
yeah.
That one that's just on the CNC, like so you could do the same.
Yeah, so kerf bending more broadly, you can do on the CNC, but you can also, like in this case, it's probably a sheet of, I'm not really sure, but it looks like it's probably on a table saw where 1/8 inch cuts are taken away and then you bend that way. Kerf bending is a neat trick where you can get a lot of cool dimensionality out of a material. This, yeah.
How do we not go through the phone?
Oh, you just got to very carefully dial in the depth of the cut. Ada, have you actually done kerf bending on the table saw? I feel like
The curves were the curves were smaller than the table saw curve, so I used a CNC.
oh, well, there you go.
But I've done curve bending that looks like the table saw version. Yeah,
Yeah.
that's what that is for sure.
Yeah, this is definitely a table saw, just to see the way that it looks, like a sheet of plywood that was bent. But there's tons of cool ways to do this and get it to come out in a lot of different configurations. So it's definitely worth looking into if you want to like level up your maker nerddom. This is a good way to do it with this kerf bending stuff. It definitely buys you some maker street cred to have done kerf bending like this. And then glue usually to reinforce, or maybe a wood filler if you have gaps that you want to fill and you don't want this look to be the part of the feature. You can fill it with things or do a veneer over it so that it hides it. But usually I like the look. It's kind of a fun textured pattern. So it depends, whatever you're going for.
It it's like the inside of a drawer or something like that.
Yeah, that's true. Yeah, that's what yours was, the inside of a drawer, wasn't it? Yep. And so cool. So those are all sort of normal laser skills. But if you already 3D design things, if you want to level up your skill more, and I'm thinking about you, Seenam, this is where you can go from 3D modeling straight into the laser. And we're going to circle back to this later on in the course, but DXFs are digital exchange files, and they let you go from a 3D model, like this is the dust shoe on the Gerber. You can go from a 3D model of what you think that's going to be into 2D cut files in Corel Draw or Inkscape or whatever. And so it's a really neat way to be able to model in 3D space what you want to make and then get 2D cut plans from it. It is not a beginner 3D modeling trick, but it's a really good trick if you wanted to do something like that and make sense of it. By doing it this way, I was able to sort of model out the spindle and its geometry. And then I told Fusion 360 that was sheet metal that I was bending. And so I could leverage all sorts of crazy tools in Fusion 360 to make this into sheet metal parts that would be bent and unbent and do all sorts of crazy stuff with it. As you get better and better at all your modeling skills, you can really push the limits of what it takes to do 2D or 2.5D building. And there's lots of cool opportunity with that. But it's definitely a more advanced skill. So laser projects. Laser projects can take any sort of form, and we want you to take on whatever you feel is your level this week. You can do acrylic cases for electronics projects. Here's a cardboard iris. This is a perennial favorite, snazzymaps.com. People buy and sell maps of their town with the rivers and the roads all shown in, with them like raster engraved onto a piece of wood for hundreds of dollars on Etsy. You can absolutely go on to snazzymaps.com, download an image, hit print, and have it for the price of the wood and an hour. So this is completely something that you can do. There's different configurations that are pre-made for doing this with the laser. But it's a really nice effect that you can get of your favorite town, of your favorite, whatever. I don't have a picture here, but a friend of mine, for my 1-year anniversary with Carolyn, I had a friend of mine who's very good at doing this, make a relief of the lake bed where we got married. And so it's like the relief of the bottom of the lake and then a little heart where we were actually at around the lake. It's cute. So there's people who can get really artsy with doing all this sort of stuff with the laser, and you can get all sorts of cool stuff. Like you can also engrave in real photos. Getting the settings for something like that exactly right on a piece of wood with grain and texture on it is not easy. I don't want to sell that as like, oh, you have a picture, you put it in and it works. You've got to dial in the contrast to be just right. The material matters, all sorts of things. It looks like this is a stamp or a different setting. This is like a high art on the laser. If you can do that well, someone should be paying you to make things. Versus this, which is like also really nice, but you download it from boxes or from boxes.py and it works. So there's all sorts of cool stuff. Do any level of these, whichever one you want. And that's really the goal for this week. How do you get started with this stuff? You could read the Center for Bits and Atoms laser tutorial if you felt like really reading all the details and getting all of the context for it. You could go to MakerCase or Festi and just print something out. You could laser cut your maker's mark since you already have SVGs that we've made the whole time. You could find a bitmap and convert it to vector and then engrave it. So make your own SpongeBob or whatever. Teenagers in a high school really love to do this with their favorite logos or cartoon characters. You could design your own art and engrave or cut it out. There's some really cool stuff that people have made. Ileana made ghost earrings that were really cool that she had designed that came out really nicely on the laser out of acrylic. Or you could do multiple colors and do that sort of false color mapping if you wanted to try and get better and better and better at engraving. You could engrave one of these faces. I gotta emphasize, that's hard. Don't think that that's just gonna work. It'll take a lot of tuning and getting it wrong many times. But those are the things that we want to invite you to try this week, to explore these ideas with the laser, to make cool projects like this or like any of these. Just wander your way through and find something that you want to try, whether it's raster like this, where you're designing on top, or whether it's engraving, or if you want to do sort of a combo of any of those things. All of these are cool options for projects that you could take on this week. The nice thing is that we are cruising in on some New Year's holidays, some other holidays. And so if you've got presents that you need to make because you haven't seen family in a while and you need to produce something, the laser is a great way to do that quickly. And so this is I think that the year that we did these for our family, I made 24 of them with different family names in the thing. It's a great way to make a custom piece. If you were to buy those online, it costs a lot, whereas the piece of wood downstairs is like $7. And so if you can make 24 for $7, you're winning for sure. So there's some cool options in here. You can make decorations for the new year or winter solstice or whatever it is that you do. So lots of different options, but our suggested path is to try and work your way through any of these options that you think are going to be lots of fun. Yeah.
So you can't put that in the laser. What if people make like nameplates out of? Like I wouldn't have mine right now, but I have like a.
Oh, that's a good question. Also, we should turn on the mic and start handing it around for things. So what do you make a nameplate out of?
What kind of metals?
Look on the site that I bought it from. I think it's sterling silver, stainless steel or something like that. Aluminum, yeah, sure.
Oh, hey.
You guys do with the mask on?
Yeah. Well, especially I think because we're talking about metals. But yeah, I mean, it might be a CNC engraving. But then there are, for like more expensive applications, there are lasers that do cut that. They're just not the kind that we have.
And
They're like,
you can do some metal applications, right? You can't cut them on our lasers, But if you have like anodized aluminum, that
Yeah.
anodization is really just like a single molecular layer of chemical treatment on the aluminum. The laser will burn that away and it looks etched, but it's not actually etched into the metal.
That's every MacBook is that. So if you have a MacBook, you can pop it in the laser and customize it to your heart's content.
Yeah. There's also, I don't know if we still have any in the fridge, but for a while we had stuff called marking compound. You can also buy dry moly lube, which is an automotive product that does the same thing. And you spray it onto steel, or I think brass will do it as well. And the laser catalyzes that and it basically fuses it to the metal beneath, and then you wash away the rest, and that black marking stays. Like the actual dedicated stuff is, $100 a bottle. The lubricant is like $30 a bottle or something. So, not a low bar of entry if you're just looking to experiment. But if you have some downstairs, definitely check the chemistry fridge at the molding station. You may see some in there.
There's also, lots of desk signs are just acrylic with like a thin red layer or black layer on top of white, and then you blast away the black topper and you get really nice crisp white lettering underneath for like, office desk engraving stuff. Not as nice as the metal ones, but it's something.
I'm also thinking like something that you put like, I think there's a certain name, whatever says like, or something like that. And I was wondering what like people, what people use to make that?
Yeah.
Higher power lasers?
There is a
Yeah, well, I mean, it is a higher power laser, but it's also like, it's a different frequency that the heat just gets like pushed through the whole piece of metal too quickly with that kind of laser, and so it can't actually like do any precise work on something like copper or silver. But those lasers that do, what are they?
Fiber lasers. Yeah.
Those are extremely expensive.
Yeah, they're
Like $60,000 to $100,000, something like that, I think.
I mean, each of the lasers that we have downstairs are probably $25,000 each.
Yeah, but the $60,000 laser is for like has a workspace like about that big. So
Oh, new ones, you'd be shocked at the new ones. I've been shopping for lasers recently, and they're like, you're cruising in on luxury car prices for these fiber lasers, but they can hit a 3-foot bed.
oh really?
Yeah, there's some really cool ones where they're dual or where they have both types of laser tube. But now you're talking brand new lasers bought directly from, like, those aren't the lasers that we have.
Yeah. But I think like most of those things would probably be done with either like a CNC machining tool, like in the metal shop, or with there's CNC engravers. There's also one in the metal shop, I believe, but I don't know if anyone's gotten it going yet.
I've used it. So I've used that CNC engraver sort of, and it kind of works. It's not great, but it does turn on. Oh, somebody.
It's a very different method of like making the mark.
Yeah.
on it, so we might just not have gotten it dialed in yet.
Right.
I haven't used it at all, but because you're not like cutting away, you're just like making an indentation.
Yeah, you're just making an indentation. It really reminds me of like the old school, you're engraving a calculator. I do this a lot with high schoolers that get new calculators. You have this weird pen that just shakes a lot, and you're just grinding away at the plastic and putting a name in. So you write Charlie in a weird vibrating script font. That's sort of how it makes those nameplates, but it comes out really nice because it does it methodically instead of like a weird shaky by hand method. So yeah,
A lot of it's also probably cast.
that's true. Casting is a magical process.
But not the kind of casting that we can do here either.
Yep. All right. Cool. Any other questions, thoughts, concerns? Or otherwise, maybe show and tell time. Okay, cool. Let's do show and tell. Let's do. Arvia, do you have any, you want to show and tell anything that you've been up to this week? Sure. You should be able to go from there and I can cut you, yeah.
Yeah. So my plan this week was to do the vinyl and the laser cutter. Okay, so I started a sign. I cut this out last week. I don't know if I can take it out because it might be jammed in here, but these are two separate pieces that I designed in Inkspace. And my plan was to have that with some vinyl with like my business name on it, but then have the Instagram logos and TikTok logo and all that stuff in acrylic. So I cut these out. They burnt a little bit, so I need to like wipe them down or clean them off. Here's the Instagram pieces of the Instagram logo. So basically when it's complete, hopefully next week I'll come in with it complete. I'm gonna adhere onto the acrylic. Oh, sorry. Yeah, that is showing. So I'm gonna adhere these onto this acrylic, and then I'm gonna put some cut and vinyl, like my website, my business logo, Instagram and TikTok name, and then like the business website. I started doing that at home with the vinyl, with my Cricut, just because it's easier to do some of that stuff at home. That I work out my frustration there.
It's fair.
Like the first try at the vinyl, I used a really thin font, and the weeding, I was just like, all right, we need to take a step back from this. And so I'm gonna do another go at that. So that's basically it. I don't know how I'm gonna adhere these. In my head, it seemed like such an easy thing to do, but then in practice.
Yeah.
Yeah, so these were this. And then I'm sure that crackling is annoying. This was all acrylic actually that I found at the laser cutter. One day I was down there and there was so much acrylic, somebody just left it there for scraps, and acrylic is really expensive, so I lucked out honestly and grabbed this stuff. I have more in my car, so if people want some, I can share honestly. But yeah, I'll put out acrylic, the little pieces. I wonder if y'all have suggestions on how to adhere it and how to clean. Well, this is some of the backing I can spill off, but how to clean the acrylic.
Acrylic. Oh,
Just say way back when I made a box out of acrylic and ice cream.
mhm.
There's this chemical in the bottle, I still have it.
Yeah.
The applicator with a needle tip, and then just run it along the edge, and it fuses one piece to the other.
It's pretty, yeah, acrylic cement like that is pretty magical. It really like, it sort of mushifies the acrylic and then reconnects it. So it's not like it's different than glue, where it's a thing between the two materials. It actually fuses them into one piece of plastic. So it's a really cool process. And I think it's worth trying with a clear and a white piece, just to see that it doesn't do weird things to the color. But if it works, that's like how they put together lots of fish tanks, is they'll do that down the seam and it makes it into one solid piece of acrylic if you've got an acrylic tank.
So even with something thin, with
Yeah,
thin
it
lines
should-
like this?
It's a super thin liquid, so it like wicks its way into the cracks between the two materials and it fills it in.
Okay.
It's unbelievable how well it works. It's how that dust shoe got put together. I cut a bunch of tabs and then it just sort of wicks its way into the cracks and then fuses it together into one piece. So
Okay, I'll try that.
yeah,
Any tips on cleaning this?
I think isopropyl alcohol is probably your best shot.
Okay,
Just some rubbing alcohol.
yeah, I'm
Yeah.
probably gonna paint this, the clear acrylic, just because like if I do the cement and then does something weird, I'll probably just paint the back of it so that the front, it looks like it's a.
That could be great.
So yeah, hopefully next week I can bring it in and it'll be complete. But yeah, that's what I'm gonna do next week.
That's awesome. Cool. Thank you. We'll just pass it on. We'll go through and share?
I mean, I did very little but make lots of latkes this week.
Yeah,
But I mean, yeah, I just, to get badged, I brought a file in and decided I'd put my logo on there.
that worked really well.
My biggest hope was to do it on printable vinyl so that I could literally, but I understand that's a big deal to coincide the image I print on there with the cutting line. So I'm just gonna bypass that, but it would be nice someday to figure it out.
It's totally doable. It's just like a series of steps you got to work through.
Yeah.
And so we can sit down one afternoon and like make it happen, but we just got to be ready for it to take a lot longer than we think it's going to take.
Yeah,
So.
and I don't know when I can find the next moment now that I supposedly know what I'm doing, which of course I forget.
Yeah.
I want to try it on the vinyl that goes on fabric. So I brought just a swatch of t-shirt fabric that's not on a t-shirt anymore. And I have a scrap and I sent a file to the bucket thing, and I'll try to cut and just go through the process.
Sure. Yeah.
And then use the real t-shirt with the real. That's it.
That sounds like fun. Cool.
So I did some work on my Cricut this week, which I forgot how kind of frustrating it is. I was definitely feeling the capitalism burn a little bit. Like the first few times that I tried to import my own designs, it said that the cutting file or the cutting path wasn't supported, which was a total lie.
Yeah.
And I just imported it anyway. Yeah. It doesn't, it's so weird and it doesn't do anything. Like you can still use your own stuff. I think they're just trying to make people not use their own designs.
That sucks.
And then eventually it just stopped giving me the error. So
Well.
I don't know. That was very odd. But I made some signs for my wedding.
That's
still
lovely.
really far away, but
That's all right. You got to get
yeah.
prepped. The wedding crafts take a lot longer than you'd expect.
Yeah. Sorry, guys. So I have 3. I can get it out of here. And these still have the like backing on them, so they look a little frosted. One says like spread
Yeah.
love, not germs, and there'll be like some masks for like people that didn't bring a mask. I don't know. And then I just got these little wood stands.
Oh, that's great.
So these still have the protective backing, which makes them look frosted, but I kind of like the frosted look, so I think I'm gonna take it off and then like actually spray paint frosted.
Just leave it.
Leave it?
Yeah, I don't think
No one will ever know.
That's true.
right. It'll just be you.
This one was like, it's kind of dirty, but you guys can see that. This one, I had to redo like several times and change the amount of text and make it bigger and like cut down the amount of words. And I see people that do their entire like seating charts for really big weddings in vinyl, and I don't know how they do it. Because I had to redo this so many times, and at the end I was like shaking.
Yeah, that sounds, somebody who does that, it feels like it's a have tool will use it sort of like solution to a problem. It may not be the best solution, but it's the one they've got, darn it.
Yeah. So that was, oh, sorry.
You actually weeded out everything.
No, so for this, I actually, I looked on TikTok
Mhm.
for like, I don't know, like weeding. And I was just like, I wonder if people have good weeding hacks for like small text. And so what people did generally is you put down your transfer tape directly on the vinyl and you pick it all up and then you just weed like the remainder. Or you can just weed it, like weed the little small parts. And then you pick everything up so you're not weeding the reverse because that's really hard.
And so you pulled the part that you'd weed away, you pull off the transfer tape?
Yeah.
Oh, that could
It's
be
a
a
lot
really,
easier. Yes. Yeah, I'll send it to you.
that could be a really good strategy.
And then I just did this little gifts and cards one.
That's great.
So yeah, they're all like pretty basic, but I was pretty proud of the guest book one, so.
That delicate font is something I would not have been able to do. So if that weeding trick worked that well, I'm super duper impressed.
All right, so I got badged. When I got badged, I made the MakeHaven robot, which I think Vincent did too.
Mhm.
And then just messing around, I traced my motorcycle and made some motorcycle stickers. I made this one, which is more secret detail in there. And then I made many, many stickers of my cat. So I can stick them everywhere and just secretly have my cat all over the place. I tried to do like a multicolor version of the motorcycle, but my design skills are inadequate. So that's something that I would need to probably get better at. But yeah, it came up pretty cool. I'm gonna keep copying photos of things and turning them into cool stickers. I think there's a place that I go skiing sometimes that has like a really awesome chairlift, and I think I'm gonna do the chairlift and like 2 of the towers like pretty
Oh,
big and put it on
yeah.
my fridge probably. I was like thinking about that and like this is like, you know, works in silhouette like really perfectly and
Oh, cool.
it wouldn't be hard. So pretty cool. So that's that.
That's lovely. Cool. And I'll just dump, unless Eddie, you want to share anything? You don't. All right. So everybody in the room did their sharing. And now we've got 2 remote people. We've got Seenam and Norm, neither of whom have their cameras on. Oh, Seenam's got a camera on. And so if you would like, Seenam's camera was on first. If you'd like to share what you've been up to this week, if you have pictures of the things you made were really cute. So it'd be fun to see it.
Yeah. I also worked on some sticker making this week. I made stickers of this. Oh, I'm getting feedback. Oh, as well. Yeah. I made stickers of this animal called Pika. They're like tiny rats. It's the animal that Pikachu is based on. And I made these because at work, like we call our new prototypes Pikas for some reason. And I was like, oh, I can make them and give my coworkers some. So this is what they look like. It's a 2-layer sticker with, so I like just found this design online, put it on Inkscape, which the name always eludes me. I'm not sure Inkscape or Inkscape. I'm pretty sure it's Inkscape. All right. So I put it on there and then learned kind of how to turn it into bitmap and did the black part is that kind of 1 layer underneath, and then the gold is just a 2nd layer on top. And I had some registration marks to line it all up. It was really fun. I actually really enjoyed this, and they look very cute.
Yeah, it was a really good design, and it came out really nicely. So it's a great first win for a 2-layer sticker for sure. All right, and Norm, how have you been? What have you been up to?
Okay, I think I should share my screen though, if I can do that. I think, Corey, you need to do something to allow it.
You should be.
Okay, so is it showing? Can you hear me?
Yes.
Okay, good. Yeah, so did the sticker stuff. And then I wanted to think about doing stuff on wood. And so this is an island that I think is kind of pretty, and it's got a simple shape, really, kind of a notable shape, kind of almost like a whale or something. And so I had to learn a lot about Inkscape and also GIMP to deal with it, but because a lot of the contrast needs to be worked on in GIMP, which it's not a system I knew before, but it's a photo system, a freeware kind of thing, and it converted pretty well to a bitmap, and then did an etching with it, which came came out, I thought, pretty well. It's the detail is nice, and I think I might use it for an inlay for something else, for I don't know, a box or something. But so that's what I was up to.
That's really cool. And I like that you mentioned an inlay. A friend of mine who works at the school where I teach is just started to do inlays with the laser on guitars. So he'll raster engrave a shape. And when you do that, you get a little depression in the material that you're cutting. So in wood, you get a little drop down, and then he'll laser cut a veneer that's the same exact size and shape. And then you can glue that in. So you get a really cool inlay it's not very thick, but you can like take a really dark veneer and put it on top of a light wood or vice versa or whatever. And then sometimes some people really like the feature that like the borders get a little darkened because it has that crispy lasered look to it. So it can be an inlay with a little bit of the wood burning feature on the sides. So there's some really cool opportunity there. And we have some veneer sitting by the laser. So if you wanted to try it, you totally can.
Great.
Yeah. Awesome. For show and tell this week, I don't have any pictures to show here. Maybe I'll ask Ashley to overlay them, but I made 12 cutting boards for my holiday presents. And so that was a lot of them. We made it for all of the family that Carolyn and I have, and then some other friends who split the bill for the wood because it was a lot of expensive wood. But you know, when you spread it out for how much the cost is per present, it's appropriate. And so that's always fun to crank out those sorts of projects every so often. This is definitely we've you know, Hanukkah just ended, Christmas is coming up, there's holidays where people get together and give presents. So this is a great time to think about for your projects. What if you want to give presents away? This is a good time to, that's a nice easy win to think about, how do I make a present on the laser? So those are all good things to think about and try. So, yeah, you're good.
Best practices of how to transfer, like to do a two-part design. So like if I want to cut something out on the
Shipoko. Mm-hmm. Ooh. That is a good question. So the question was, what's the best practices for placement of something that you've cut on the Shipoko and then want to put it into the laser? There's two things to go with that. One is if you could cut it on the Shipoko, that'd be awesome. So you didn't have to have this registration problem. The second, barring that, the best trick that I know is cut it on the Shipoko and then take let's say you want to cut a heart, right? Like you have this big heart shape that's 18 inches across. I would cut it on the Shipoko, and then I would take the exact same vector and go to the laser and lay down a sheet of paper and just engrave the heart on the paper. Not that I'm going to use the paper for anything except to align where I set it down. And then you can do all the zeroing and lasering on that surface. You just use the laser to tell you where exactly it needs to be.
Done that.
Yeah.
I use cardboard for that.
Oh, cool. Oh, a registration.
It's not wobbling. You just drop it straight.
That's fair.
Cardboard. Make sure down where you cut it, you got a ready-made jig, and you can just cycle through them. You pick it up, put the next one down. If it sits, it's good to go.
That is totally fair. Yeah. Using cardboard with some thickness makes a lot of sense.
I haven't used the Shipoko on my own yet.
Mm-hmm.
But if I need first and then the design around it, does that make sense? Am I have a chapter?
I think in that case where you want to think about laser and Shipoko, I think I would Shipoko first, then laser, because you can laser on the top pretty easily, and that registration trick works really well. It's not as easy to go the other direction, unless you can like mark where the center will be, and then I would just do Shipoko to laser is really genuinely the advice. Yep. Yeah. So there's tons of cool tricks, all sorts of fun laser stuff to make. For all of you that are physically here, we can go wander downstairs and like actually cut something on the laser right now. I've got a few projects that I need to do. We can cut some stuff. We can find that robot design and cut it again out of the laser, out of cardboard. There's all sorts of cool opportunities. So that's it, everybody. We're done a little bit of like on schedule. And so let's go downstairs and play around with some stuff. All right. People who are playing along at home, good to see you. Hopefully we'll see you in the shop this week. See ya.